Let's start with a simple idea. What comes to mind when you see chemical symbols? Chemistry instantly starts swirling in your thoughts, right? These symbols are unique signatures, gateways into the world of elements and their reactions. But here's a deeper question. How did these elements come to be understood? And how were they eventually arranged into the powerful tool we know as the periodic table? In this video series, we'll answer these critical questions. The creation of the periodic table was a true turning point in the history of science. How? We'll uncover that together. First, let's explore how our concept of the atom evolved historically. Our journey begins about 2,500 years ago in ancient Greece. There, the philosopher Democritus pondered the nature of matter. He proposed that everything is composed of tiny, indivisible particles, called atomos, meaning something that cannot be cut. This idea suggested you couldn't break an atom down any further, yet this concept proved troubling. It challenged the religious norms of Greek civilization, so it never gained widespread acceptance. Then came Aristotle with a different answer. He envisioned the universe as composed of four primary elements: air, water, fire, and earth, soil. This concept found favor for two key reasons. First, it aligned with prevailing religious doctrines. Second, these four elements were tangible. People could imagine them and experience them through their ordinary senses. So, who was right? Democritus or Aristotle? Astonishingly, this fundamental question remained unanswered for nearly 2,000 years. What was happening during this vast stretch of time? This era is known as Alchemy, spanning roughly from 500 BC to 1600 AD. Alchemists focused intensely on a tantalizing goal: transforming ordinary metals like copper, iron, and lead into gold. While pursuing this dream, they also made significant practical advances. A towering figure of this period is Jabir bin Hayyan, often called the father of chemistry. When Jabir dissolved metals like iron by dipping them into sulfuric acid, the public saw it as pure magic. Through meticulous work, Jabir prepared vital mineral acids, hydrochloric, nitric, and sulfuric acids, using repeated extraction methods. Crucially, many laboratory techniques developed by alchemists, such as filtration, distillation, and sublimation, remain essential tools for chemical separations even today. The game changed dramatically in the early 17th century, marking the glorious dawn of the scientific revolution. Scientific curiosity soared, and pioneers began laying the rigorous foundations of modern science. Key discoveries emerged. Joseph Black identified CO2, Joseph Priestley discovered O2, Henry Cavendish isolated H2, and Carl Scheele discovered Cl2. Furthermore, in 1661, Robert Boyle shook the scientific world with his book, The Sceptical Chymist. In it, he boldly revived and confirmed Democritus's atomic approach, definitively rejecting Aristotle's theory of the four elements. Boyle argued pragmatically, an element is a substance that cannot be broken down into simpler substances by chemical means. This powerful definition ignited a new journey in chemistry. What happened next? How was Boyle's concept refined over time? How did scientists begin discussing and measuring the atomic weights of elements? We'll answer these pivotal questions in our next video. Stay connected.